Good day, everybody who's watching this video. Thank you for joining me today. When I'm recording this video, it is Tuesday, about 10 o'clock, and it's really windy here at LCC. We started this page on Monday when we met with our Monday group. And this is page 63 in our math notebook. We're talking about some vocabulary in modules 10 and 11, talking about expressions and equations. I'm going to zoom in a little bit so you guys can see this closer, and we'll talk about what we discussed on Monday first. So on Monday, we talked about algebraic expressions. What is an algebraic expression? It's an algebraic expression contains one or more variables and may also contain operation symbols such as plus or minus. Now, we have here an expression, 150 plus y, and the 150 is called a constant. This number is not going to change, but the y is a variable, and this could change. It could be anything. If this was 3, then if y was 3, then 150 plus 3 would be 153. But y could be any number. It could be 2, it could be 1, it could be 1,000. It's a variable. All right, so there's an expression. It has no equal sign. It's just a number sentence, no equal sign, has a constant and a variable with an operation in the middle. All right, so variable we talked about next. A variable is a letter or symbol used to represent an unknown or unspecified number. The value of a variable may change, and I put this here. This is an example. We have 3, and then the variable x equals 6. If x was 2, obviously, then it would equal 6 because 3 times 2 equals 6. If x was 3, then 3 times 3 would equal 9, and so on. So a variable can change. It has an unspecified number, and we have an example over here. Now, moving on to our next vocabulary word is evaluate. And I'm going to move this blind out of the way. You evaluate an expression when you substitute a number for each variable and then find the value. And actually, we did that up above with the expression, but I'm going to give you another example here. And this is straight out of the book. This example looks like this. If you have 1.8 or 1 and 8/10 C, and I'm going to take away those parentheses. That's not necessary. So I'm going to make the C out of blue, just like above. 1 and 8/10 C plus 32. Okay. And actually, for simplicity's sake, I'm actually going to change this to 2C. Just will make things easier to calculate. Okay. And C is our variable. I'm going to keep that blue. Okay, so what does this work out to if C equals 50? Well, if C equals 50, then I would take this 2. I apologize, hang on. I would take this 2, and that would stay the same. That's one of the constants. The variable C equals 50. So I'll take this 2. Hang on, change the color. I'm sorry, I apologize for this, guys. This is something I've been battling here. Okay, so again, I apologize. I don't know what to do here with this. Okay, so 2 and then multiplied by C. So I'm going to make parentheses here, and C is 50. So I'm going to substitute that 50 or that C with 50. And that should be blue. It's taking way longer than it should. Okay, that's better. And then put that inside parentheses. So we have 2 times 50 and plus 32. So I'm going to evaluate this. We plugged the 50 in for C. 2 times 50, of course, is order of operations. We do first parentheses, exponents, multiplication, division, and then addition. So we do multiplication before we add. 2 times 50 is 100, and 100 plus 32 would be 132. 2. All right, so we evaluated this expression. We found the value of this expression by substituting a number for the variable. Now, if the number was different, we could substitute c for a different number and find the evaluated expression there too. So this is just one example. You might also see an expression that has multiple variables, maybe like an a, b, and a c, and then you would have to plug in numbers for 3 different variables and evaluate that expression. So that is evaluating expressions. It's different than finding the solution to an equation. We're going to talk about that too. But this is where you substitute a number for a variable and then you find the value. Okay, so simplify is our next vocabulary word, and this is very similar to when we simplified fractions, right? We can simplify expressions to write a fraction or expression in simplest form. And I'm going to give you a super easy one here. This one has 2 different variables in it, so give you an idea of kind of what it might look like with 2 variables. You have 3y plus 4y. Now, because we have 2 of the same variables, both y, and we have 3y and 4y, I can simplify this and just call it 7y. I don't know what the value of y is. I don't know what the total value of the expression is. I can't evaluate it, but I can just simplify it. So I added 3y plus 4y equals 7y. Now, you wouldn't be able to do this if you had, for example, let's say you had 3y plus 4y plus 6z. This would have to stay because it has a different variable. You wouldn't be able to say 7y plus 6z is 13yz. That wouldn't work. Those variables are different. They have to be separated. So you could simplify it like this. Add the y's, the z's, you would add 2. There's only 1, 6z, and that stays the same. So hopefully that kind of makes sense. You simplify expressions, kind of like you simplify fractions. You simplify expressions the same way to show it in simplest form. Okay. Now, next, we're going to talk about equations. And feel free to pause this video if I'm going too fast. Feel free to rewind it if you need to. And definitely, if you have questions about what we're talking about, ask those questions when we see each other in class. So the next one is equation. And let me remove the blind here. An equation is a mathematical statement that 2 expressions are equal. With equations, you find the solution. So I'm giving you an equation here. This is an example, a very simple example. If you see the equation 3x equals 15, well, we kind of have 2 expressions here, don't we? We have the expression 3x, 3 times x, and we have just 15 on the other side of the equal sign. So in the middle, we have an equal sign, and this is what really separates an equation from an expression. You're talking about 2 expressions that equal each other, right? So we have expression 1 and expression 2. Now, equations can be solved. With an equation, you find the solution. Okay, and that's what I'm going to do here. I can find the solution to x. And this is new to you guys. I'm not expecting you to fully understand what I'm doing here, but my job to find the solution of x is to get x by itself. We've talked about this before, but if I can get x by itself on one side of the equation, then I'm done. I know what it equals to. Okay, so to do that, I'm going to get this x by itself by dividing 3 on both sides. We've talked about this before, I know, but 3 over 3 is 1. So those get eliminated. Basically, you're left with x by itself. And 15 divided by 3 is 5. So x equals 5 in this case. And I'm going to circle my answer. All right. And this is an equation. You find the solution. In this case, the solution is x equals 5. All right, finally, we have a little bit more vocabulary for you guys to write down. We're going to be writing down or translating written words into expressions. And sometimes students get confused about what these different words mean. So I have these words for you. When you are adding 2 numbers together, or a variable and a number together, a constant together, you might see the words added to, plus, some, or more than. If you are writing down a subtraction number sentence, you might see words like subtracted from, minus, difference, less than. If you're translating a sentence into number form with multiplication, you might see words like times, multiplied by, product, or groups of. And of course, if you're using division, translating expressions that were written in word form into number form with division, you might see words like divided by, divided into, or quotient. So these are important words to know. When you see these words, you're going to be using these operations. And I definitely want you to write this down. This is something you will see on future quizzes. So I'm going to zoom out all the way. This is page 63. We did the notes on page 63. Hopefully you guys have paused the video and taken your time to write down these notes in detail to have good notes, so that when you take the quiz, you have good notes to rely on to get you the best score possible. All right, ladies and gentlemen, thank you for taking notes with me today, and I'll see you in the next one.